Okay, this is a continuation of the first video explaining what a function is. So I want to give another example to illustrate what a function is, and as I said, it's very simple. It's just interesting to see and to analyze how they're all over the place, the functions. Just every minute of the day you bump into a function. You just don't realize it. Just like you don't realize that you breathe and your heart beats every day, every second or every minute. Okay, the example here is going to be you go into a store, into ShopRite or Rite Aid, or into a bank, and you make a deposit or you buy stuff. So there's some big stores, supermarkets have like 10 cashiers. Now, let's assume that today is Friday. The store opens up from 6 o'clock, closes 12 o'clock midnight. There was in the store altogether, let's say maybe 5,000 people. It's a huge store. 5,000 people were there throughout the day. I'm just making up the number. I don't know if it's possible with 10 cashiers, but let's say 5,000 people and 10 cashiers. Now, you're waiting in the line to check out. You just bought a wagon full of stuff, and you can go to cashier 1, cashier 2. You try to figure out which is the shortest line, or which one does the. Sometimes you can wait in the line. You see the shortest line, but that simply doesn't move because the cashier doesn't know how to. She doesn't know how to type in, how to do stuff. Everything takes her 10 times the amount. So you're just trying to see which one you want to go. You decide to go to cashier 7, cashier 8. You make your decision. So now, here's the trick, and here's the interesting phenomenon. It's just so simple, but it's nice when you talk it out. Each person can only check out by one cashier. You make up your mind you want to go to 7. You can't start off with 7 and then go to 8. No, once you start at the 7, you have to finish checking out the 7. So each of these 5,000 people chooses one cashier. So here is the people that enter the store. They are the box A, and the cashiers are the box B. And the function is the power or the energy or the angel that tells you to go to whom, to connect your body, your soul with that specific cashier. And many people can use the same cashier. Obviously they see that this is a good line, it goes very fast, so everybody runs away from one of the cashiers. They all use that cashier. That means that's a 100% legitimate function, because every of these 5,000 people uses one cashier. So if we line it up this way, we take the people in the box A, cashiers in box B, and we affiliate every person with one and only one cashier. That's how it is, obviously. Then this is called, in the jargon of math, a function, because that's what's happening here. We're taking each person, we're assigning to him a specific cashier. However, let's say that at the end of the day, the boss, the manager, takes all these cashiers and asks them, which patients did you serve today? So everybody takes out a list. I served that and this and this and that and that, the whole list of patients. I want to see who did the best job. So here we want to do vice versa. We're taking in box A, we're taking the cashiers, asking them, whom did you serve? So they give out a whole list of people. Nope, that's not a good function. That's not called a function. I don't know how to call it. That's called a function. You make up your own name. Called a function. A function is not this. If you give out, but we take you in consideration, and you return, you output many different things, many people, it happens to be a slow store that the 10 cashiers, each one only handled one. Okay, if that happened, so there was only 5 people and 10 cashiers, and by chance each cashier and no cashier had two people. That could happen. If that happened, then you're lucky. Then you get another function. Then you can also say that the cashiers are the people are box A, and the people are box B, and each one you assign for each cashier a person to take care of. But that's not natural, so whatever. So we say if you want to make a function out of this situation, you better put the people first, use them as box A, and the cashiers as the box B. That's how we should order them in order to make this into a function. If you want to make it into a function, so you have to do it. If you decide you want to create a function, so this is the way to create it legitimately. Take first the people and assign to everyone which cashier took care of him. And let's not forget that it can also, it's 100% accurate to say that okay, let me explain this. If we say a person came into the store and he just left without shopping anything, that's no problem. That's also a legitimate function. It means that he has no, that's okay. He just walks in, he goes through the aisles, he doesn't like anything, he goes. So on that list, he still belongs to the list of the 5,000 people. Because when we count 5,000, we mean everybody who entered this store. We could limit ourselves to only people who shopped, but it's not necessary. We can use in box A every single person that entered the store, 5,000 people. They went through the doorpost during that day. So they can be counted in box A, no problem. And you can say that only 4,500 of them shopped and the other 500 just left the store. So when we write the function, we say, okay, on these 500 people, there's so-called the input is the person, and the output is non-existent or undefined. I don't know how to call it. That's okay. But to say that a person came in and he shopped and he had two cashiers, that's really nonsense. You cannot do that. It's impossible to happen. That's why it's a good function, because it has this property that each person has only one cashier taking care of him. Many people can have the same cashier taking care, not a problem. So I hope this is clear enough. Now, obviously, in math, it goes all over the place. You use it with graphs. Y is equal to x squared, y is equal to sine x. And x is always the box A, as I call it, the input value, if you wish, and then the y is the output value. That is the y-axis. And as they say, if they teach you in high school that there's a line test, means that you draw a vertical line and it only hits one place, and then it means it's a kosher function. If not, then it's not a kosher function. You have to make it into two functions. Whatever. This is really math that you can learn in school. But I just want to show you that math is really simply taking God's world and looking at it in very general terms and see how much similarities and how much different things that seem differently superficially have really a certain sharing inner thing that they share together with the wisdom of God, how He created things to interact and to happen. That is the beauty of math. It's connecting a lot of things in the world together. Okay, I hope you enjoyed this second lecture. Thank you.